Another topic we really emphasize in our prep chem classes are conversions. So we're going to do a brief review on conversions, and I have a few example problems for you to try to see what you can recall on the whole conversion process from your prep class. All right, so we've got our international system base units, meter, kilogram, second, Kelvin, mole, ampere, candela. Now, sometimes when we do conversions, we have to do conversions between English and metric units. Sometimes we have to do conversions between metric and metric units. For example, in the lab, if I am getting the length of something, typically I'm measuring that in centimeters. If I'm getting the mass of something, I'm typically measuring that in grams. When I then need to use tabulated data from something like the CRC handbook, oftentimes that's done in international systems, so meters or kilograms, things like that. So even within science, we very frequently have to do metric conversions as well. But especially as scientists in the US, we do end up having to do a fair bit of English metric conversions, which are really important. Okay, so here's our conversions between the metric system. Metric system's entirely based on powers of 10, and so basically converting between the metric system is a lot of essentially moving a decimal point. Okay, here are some very common conversion factors. So some US conversions. You may be familiar with some of those. You may not be as familiar with some of those, but they're good to be familiar with. Even if you're provided with conversions, it's still really good to be familiar with them, or especially even know how to use them. So this is very interesting. So I gave birth to my daughter in 2020, so not that long ago. And when she was born, they, when after we had our time together, they took her to clean her up and weigh her and everything, and they did not weigh her in pounds. And my husband is like, well, I don't speak metric. That's my wife's area. What is she in pounds? And my nurses take the, enough chemistry that they learn all the conversions too. My nurses went, we have no idea. They didn't even remember what to do to figure it out. So about an hour postpartum, sometimes I can do the math in my head. That was not a moment when I could do mental math. So I asked my husband to hand me my phone, and I pulled up my calculator app and I ran the conversion real quick and was able to tell him what our daughter weighed in pounds. So these things come up everywhere. And I've been noticing more and more in the medical field that, when I go in for stuff, that they've done a lot of converting of everything over to metric, but most people, they don't really know the metric system around here. They're still using the US system or the imperial system. And so it's good to know your conversions in a wide variety of areas. Okay. This slide, these are just some of the most common conversions. So these are the types of things that I used when I was, letting my husband know what our daughter weighed, or we were buying a camping trailer, and my Escape only has so much of a tow capacity. And so when we were sitting in the sales office, I knew that we could tow the trailer no problem with its dry weight, but I was curious if we could ever fill the tanks and tow it, like if we ever wanted to go dry camping in a place where there was no hookups. And so I looked at the capacity in gallons of the tanks, and the standard density of water, we just use 1 gram per mil for basic things. And so I sat in the sales office and I real quickly converted gallons of water to pounds of water to add that to the weight of the trailer itself to figure out if my car would strain or not towing it with the tanks full. So useful places conversions come up. All right, so here's my first example for you. All right, you've got an hour-long lecture, but you start thinking in other terms. What's actually going to take greater stamina and endurance, that hour-long lecture or a lecture that lasts a microcentury? So let's think about this. Okay, so what is this problem actually asking you? Where it's asking you to do a conversion. There's 2 ways you can do it. You can do an hour to microcenturies, or microcenturies to hours. Okay, I'm going to do the microcenturies to hours. So if you're trying to figure out how the best way to go about a conversion problem is, if you're a little rusty on them, you can set up a roadmap. So our basic thing that we're looking at is this right here. Okay, this is our starting point and our ending point. Now, sometimes it's a single step conversion, and we do actually have just one conversion factor that we can go from our start point to our end point. Most of the time, especially at this level, what we're looking at though is a series of steps, okay, where I don't have a direct conversion for a microcentury to an hour. And if you do, I know you looked it up on Google. I have a series of conversions, okay? I can go from a microcentury to a century, okay? And then I can go from century to years. I can go from years to days, and then days to hours, okay? So there's my roadmap. And so I have a lot of microcenturies in 1 century. So I have 10 to the 6th microcenturies in 1 century. I've got 100 years in every century. I have 365.25 days in every year, and I have 24 hours in every day. So now I have a roadmap that I can take to do my conversion. Okay, so try it. Pause, see if you can set this up, and then unpause and check from what I do. All right, so let's see how you did. So we're going to do our 1 microcentury. Okay, times our 1 century for every 10 to the 6th microcenturies. I have 100 years in every century. Okay, I have 365.25 days in a year, and I have 24 hours in 1 day. Okay, and everything is all set up for proper dimensional analysis, because when we're doing a conversion, it's not enough to convert just the numbers. We have to convert the units too. And so this way that I've set this up, this is the standard way that we teach conversions. This is what I expect to see from you all going forward. You need to show me not just the number, but the unit as well. Sometimes you're going to have a situation where you have 1/1, but you still have to show it, because you've got to show how the unit converts, not just the number. And this is important. NASA once crashed a really, really expensive probe into the surface of Mars because somebody forgot to do a conversion between US units to metric units. Okay, so this is important. You want to make sure that you are showing the whole step process and that you are showing proper dimensional analysis. Okay, so when you run the numbers on here, you get 0.877 hours. Okay, so 1 hour is greater than 0.877 hours. Therefore, the 1 hour okay, that 1 hour lecture takes greater stamina and endurance. Okay, here's my next example for you. Okay, so again, same thing. What I want you to do is I want you to read through the problem, okay, because conversions are something that theoretically you have already mastered in the previous course. All right, so I want you to read through this, and then I want you to try it before you unpause the video and see how I solved it. Aerogel is a really cool substance. The 2 pictures I have on the slide, these are images of what aerogel looks like. Okay. All right, hopefully you have tried solving the problem, okay? Because remember, when it comes to test time, I'm not going to be there solving the problem for you. You have to be able to do it. So if you only ever copy down what other people do and you never actually challenge yourself to do it yourself, you're not going to be able to do it on a test. You may be able to go, oh no, I can totally replicate that when I get to a test. No, you got to try it. You've got to force yourself. Learning takes work, okay? It's a productive struggle. It should be a struggle. You know, I spent hours studying when I was a student, okay? So it's part of the process. All right, so if you've read through the problem, okay, what you are looking at in this problem is you have a situation where you've got space for insulation that's in centimeters cubed, and you want to know how this is going to affect the mass of the spacecraft. And so you're going to go from centimeters cubed over to grams. Okay, now in the problem you were given a density. Density is how we go between mass and volume. Okay, now the density was given in inches cubed. So our roadmap, we're going to have to go from centimeters cubed over to inches cubed. Okay, and then from inches cubed, we're going to go to pounds, because that's what our density was given in, was pounds per inches cubed. Okay, but we asked for grams, so then we're going to need to go from pounds over to grams. Okay, so we have 2,510 centimeters cubed. We have 1 inch for every 2.54 centimeters. Now notice that it's centimeters cubed and inches cubed, so we have to cube the conversion factor. Okay, so I put a parenthesis square. I can't just put cubes on the units. I have to cube the entire conversion factor. So basically what I'm saying is I'm taking 1 over 2.54 times 1 over 2.54 times 1 over 2.54. Okay, it has to be all 3 instances of that. Okay, I'm converting from volume over to mass. So my mass goes on top. So I have my 0.00011 pounds, 1 inch cubed. And then I have my 453.6 grams for every 1 pound. Okay, so I do this, and my aerogel is going to add 7.65 grams to the mass of my spacecraft. Okay. All right, here's my next one for you. You've got this ore bed, you've got this mine. The mine operates on a 20-hour day. You want to continue to get this profit. Now, you know, you have to figure out that, you know, it costs an amount to do something and you sell it for an amount. So one hint here is that profit is equal to the sale price minus the cost. So if I take my sale price of $1,335 minus my cost of $860, I get a profit equal to $475 for every ounce. Okay, so there's a hint for you. Okay, now this one's going to be a little more challenging because we want to know trips per hour. So trips over hours. So you have to convert the top unit and the bottom unit simultaneously on this one. Okay, so this one's a little bit of a challenge. So again, try the problem. I know that my face is cutting off part of it down here, but hopefully you downloaded the slides from Canvas before you started trying to do the lecture videos. If not, pause and go pull the slides on Canvas and you'll be able to read the whole thing. Okay. Let's see here. Let's give this a shot. Okay. All right, so you're starting off with dollars per day and converting over to trips per hour. Okay, so you're converting the top. You're going to go from dollars to ounces to tons to trips. The bottom is easy. Bottom is just day over to hours. Okay. All right, so we started off with our so we want to maintain that $135,000 a day profit. We have 1 day at our mine is equal to 20 hours. Okay. All right, 1 ounce nets us a $475 profit. Okay. And that's 1 ounce of gold. And in 1 ton of ore, we only have 0.0350 or 35, yeah, ounces of gold. And then in 1 trip, we can haul 85 tons of that ore. So we can check real quick. My dollars are canceling, my days are canceling. Okay, my ounces are canceling, my tons are canceling, and I do indeed have trips per hour. Okay, and so we're going to get 4.77 or 4.8 trips per hour. Okay, all right, now when I was advancing my slides, something went haywire for some reason, and I'm not really sure why, but it didn't display the empty page I needed to solve this problem. So it skipped over the density of alcohol slide. So if you're looking at the slides downloaded from Canvas, there's a slide that says the density of alcohol is at 20 degrees is 0.79 grams per mil. And so it wants to know how many liters of alcohol would you get if you bought a pound of alcohol. And so I'm going to solve that on this slide. So again, same thing, pause, try it yourself, and then take a look here. Okay. All right. If you unpaused, what you're doing is you are going from pounds to liters. So the full roadmap is pounds to grams to milliliters to liters, okay? And so 1 pound, we have 453.6 grams in every 1 pound. Our density was 1 mil per 0.79 grams and 1 liter for every 1,000 milliliters. So you should get 0.57 liters of alcohol. Okay. Now, also in the problem, I mentioned the density of benzene. Was that needed? No. Sometimes in problems, you're given extraneous information you don't need, because that's like everyday life. Sometimes you have extra information that you don't really need to solve a problem. And so that's one of the, this was not a hard problem to solve. This was a very basic conversion. But the trick in this one is understanding what piece of information you need and what piece of information is just there because it's there and you just need to filter it out. Okay. All right, and then the last example here is just another one using squared or cubed units just to get that practice. This one's just going from inches cubed to centimeters cubed, and so again, so we would take our 25.4 inches cubed, and we have 2.54 centimeters in every 1 inch, and we cube the whole thing. And again, that's just basically all this is doing when I cube the whole thing is we're saying we're doing 2.54 centimeters over 1 inch times 2.54 centimeters in 1 inch times 2.54 centimeters in 1 inch. That's all you're doing when you cube the whole thing. Okay, and so what you should get is 416 centimeters cubed. Okay. So conversions, we're going to use them all the time. So good to be very smooth and very familiar with these.